fact, there are two of them, as you know. And what does the eye do? It takes light, which is actually photons moving in a waveform, and converts it into electrical impulses which are perceived by the visual center in your cerebral cortex. The light comes through the pupil opening. It comes through transparent skin called the cornea. It comes through the pupil and then accommodated by a lens. And then the lens converges the light to the correct focal length onto the retina at the back of the eye. And the retina is full of lots of rods and cones which convert this light into electrical impulses, which then travel up the optic nerve through the optic chiasma to the cerebral cortex, to the visual center, and then your brain, what the brain does next is to get hold of these electrical impulses at the visual center and correlate them with other senses, for example, hearing and smelling and taste and touch, and tell you, and also proprioception, which is just the way your muscles and joints and tendons tell you where you are in time and space. It's all fantastically computed in your brain. Now the eye is very carefully made. Of course it is, because it's a camera. In fact, there are two of them. I'm not going to go through all the anatomical details of an eye, but the eye has to be a certain pressure in order to maintain its spherical shape. The lens has to be exactly right. The focal length from the lens to the retina has to be exactly right. And the exact amount of light has to be let in through the iris, and so on. And what's more, there are blood vessels called arteries and veins, which bring oxygen and other nutrients to the cells within the eye, and then veins to take waste products away. And they had to be carefully designed because this is a high pressure system, you remember. Now, the eyes are actually biological movie cameras that work together, adjusting for light and accommodation literally millions of times every second. We're not aware of it, but our eyes are actually scanning and moving all the time. There are three types of different movements that our eyes make. And they have to be synchronized by our muscles, which are synchronized by our brains. Now, this is what Charles Darwin had to say about the human eye. It's quite interesting what he has to say. I'm not trying to be rude here, I'm just telling you what he actually said. This is what he wrote in The Origin of Species. To suppose that the eye, with all its inimitable contrivances for adjusting the focus to different distances, for emitting different amounts of light, and for the correction of spherical and chromatic aberration, could have been formed by natural selection, seems, I freely confess, absurd in the highest degree. What's he saying here? He's saying that the eye is really complicated, and to think that that's formed by natural selection seems, according to Charles Darwin, absurd in the highest degree. Well, I have to say, I agree with him. It does seem absurd. I think it's really, really absurd. This is what Charles Darwin also said. If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. Well, I've just introduced to you something called irreducible complexity. In other words, an eye will not function unless it's perfect first time. And I submit to you, Mr. Darwin, that this eye could not possibly have formed by numerous successive slight modifications. No, it had to be perfect first time. Now let's look at the creation of planet Earth. Now this is actually a miracle in itself, another example of irreducible complexity, according to all the parameters that had to be absolutely perfect for life to survive on planet Earth. The temperature, the rotation period, the oxygen content, the carbon dioxide content, the magnetic field, the gravitational field, the food available for mankind, the fresh water available for mankind, the shielding from X-rays and gamma rays from outer space, and lots of other interdependent parameters all have to be absolutely perfect, and there's no variation, there's no possibility of any mistakes. For example, if the Earth was 1% closer to the Sun, all the water would boil. If it's 1% further away, all the water on the planet would freeze. That's just one of literally millions of parameters which actually have to be perfect. That's how God designed it. Now, I told you earlier in this presentation that this planet is young. It's only 6,000 years old. And this is actually supported by science. The Bible clearly states it, but this is also supported by science. We're going to look at the moon now, which actually recedes from the Earth. In other words, it goes away from the Earth by 18 inches every year. There you can see the Moon, which is approximately 238,855 miles from the Earth. It actually varies a lot because it's on on an orbit, and the actual distance from the Earth varies. But the point about the Moon is its proximity to the Earth causes the tides. I don't know if you can see the Moon on the right there. Well, the water that's nearest the Moon will simply be pulled towards it by the gravitational field, and then you'll get a high tide where the Moon is and a low tide at the North and the South Pole. That's to make it very simple. All right, now there's an inverse square law. I'll just tell you what it says. The force of attraction between two objects is inversely proportional to the square of the distance between them. That's complicated, but I'll make it simple. It just basically means the closer the Moon, the higher the tide. Now, the Moon is going away, so it used to be closer. The Moon is going away 18 inches a year. It used to be closer, which means that Adam and Eve, 6,000 years ago, there wasn't probably a lot of water on the Earth then, because that was before the flood. But were the tides then, they would be a little bit higher because of the gravitational fields. However, 4 billion years ago, that Moon will be much, much closer to the Earth, which would mean catastrophically high tides, tsunamis twice a day. People will be wiped out by 2-mile-high tides twice a day. It's very difficult for anything to evolve when you're being drowned twice a day. And I'm not trying to be trivial, but this is really a fact. This is a real problem. Now, the Earth is actually slowing down. Everything's going downhill. I told you that. It's due to entropy, the second law of thermodynamics. The Earth is slowing down, and we have to add a leap second every year. At the moment, the Earth is spinning 1,000 miles an hour at the equator. That's how fast it's spinning. And we've just gone past New Year on the 31st December 2008. And this is what the BBC had to say about it. The New Year arrived this year a tick later. New Year's Eve is proving particularly tricky for the engineers that look after Big Ben, because they're having to introduce an extra second just before midnight. This is what it said on the BBC News on New Year's Eve, 31st December 2008. It said, an extra second to keep the United Kingdom on time. The timekeepers who look after the Big Ben will have to adjust its clock, because a leap second will be added onto official clocks around the world at midnight to account for the Earth's slowing spin on its axis. London's Big Ben, whose bongs bring in the New Year across the UK, will have its great clock adjusted. And the BBC will have to add an extra pip to mark the delayed start to 2009. Now, actually, there have been 23 leap seconds that have been introduced since 1972 to keep Greenwich Mean Time, that's internationally defined time, and the Earth rhythm in synchronization. Now, the International Earth Rotation and Reference System Service, which is the IERS, occasionally adds a leap second to the world's timescale to keep internationally defined time and the Earth's rhythm in synchrony. So there have been 23 leap seconds introduced since 1972, which means that the Earth used to spin faster. It's slowing down, so it used to spin faster. 6,000 years ago, the extra leap seconds means that every 18 months, 6,000 years ago, the extra leap seconds added every 18 months would have meant that the Earth was traveling a little bit faster at the equator. Just maybe, I don't know this is right, but that may be why we now have 365-day years instead of the original 360. I'm not sure that's right, but that may be. However, big however, 4 billion years ago, the Earth would have been traveling at 5,000 miles an hour at the equator. So even if you survived the tsunamis twice a day, you'd have a major problem, because the centrifugal force would cause all the dinosaurs and everything else to be thrown off the Earth by the centrifugal force traveling of the Earth spinning at 5,000 miles an hour. Now, the oil wells are all less than 10,000 years old. All the petrol and all the diesel you get for your cars comes from oil wells, which are all young oil wells.